Hello friends, welcome back to Plant Science Tools. In this video we will discuss about the z-test, but in this video we specifically discuss about the graphical presentation of z-test that we have performed in the previous video, and we have interpreted our results and we accept the null hypothesis in the previous video of about the z-test. But here we are going to present our data in a graphical presentation form. So first of all, that we have a same question that is about the 10 weights in kilograms that I have uploaded a CSV file here, and then we need to about to test the population mean weight of 68 kg. So here are the basically all the same steps that we have discussed in the previous video. So that's why we are going to the next step. So the next step our is this computation that is basically we have done in the previous video. So that's why we basically focus on the directly the result. So after result you can see that the one sample z test that is basically about the z value, that the p value is basically greater than the our significance value, which is about the 0.025. So now we are going to about the step 5, that is interpretation, and here we will see that our interpretation, that you can see here that we accept the null hypothesis that there is a significant difference in mean. So as I already discussed that we accept the null hypothesis, but we want to show that this result in a graph form. So to represent it in a graph form we need a library, that is a ggplot to so we are going to form to plot the curve distribution that is used. So here we will need to specify the range factor, that is basically the 3. It's basically need to plot our curve that is very smooth. So here we are going to create a variable that is x value, and here we need a sequence function, and then we need to apply this range factor, that is in basically the sample mean minus range factor. Mean, first of all we need to subtract the 3 range factor from the sample mean and then multiply it with the sample standard deviation. Then we need to plus 3 range factor, and then we need to multiply the sample standard deviation, and also specify that the length dot out is basically 1000. So this is basically a simple way to generate a sequence of values for plotting the curve, because if we didn't work this, so there is a result of uneven curve that is basically not applicable. So after creating a curve, distribution curve, now we need to plot the whole distribution curve by using these sequence values. So as I already discussed that we are going to use the ggplot library, and after using this function, that is basically the ggplot, and then we need to create a data frame, because this data frame, in this data frame we can use our those values that we have created in a sequence of values from a range factor by subtracting or adding in sample mean and then multiplying with the sample standard deviation. So after creating our data frame, then we need to specify about the aesthetic mapping. Basically the aesthetic mapping is used to map the x variable on the x-axis. So this aesthetic mapping is used to map the x variable. This is our x variable, and here the x values from this data frame of x values. So from the x values data frame x values, only the x values are plotted or given on to the x-axis. So this aesthetic mapping is used to map the x variable on the x-axis. So after creating a data frame and to applying the aesthetic mapping or to specify the aesthetic mapping, Now we need to move further. That is basically about the stat function. Here I will use the stat functions for creating a main distribution curve. Basically, this distribution curve is created from the about all of this data that I have already given. I have already created. So after the created this data, we need to a specific function, that is basically the stat function. Here our the function is about the d norm. This is our main basically, and there we need to specify nothing, and then we need to apply the arguments. For arguments we have a list of these arguments. For example, in the first of all we are going to do specify the mean, that is basically the sample mean, and then the standard deviation which is basically our sample mean, sample standard deviation. This is our sample standard deviation. So after about, we need to specify the color of this curve, which is basically I'm going to given in parentheses about blue color. After this giving this blue color, now we need to specify with the help of geometry line to enter basically intercept another line within these lines. So if you want to add another line with the previous line, so we need an other function, that is basically the geometry line in ggplot. So I have already in written here that the x-intercept, because I want to first to intercept the x. Here our x is basically I have already discussed that this is our x line that is created by the stat function. So x-intercept is intercepted by the sample mean, and then we need to specify the color, that is we are going to of about the red. Then the line type, for example we apply here the dash line type, but we need to write it in parentheses. So after applying this line type, and we also need to specify the size. And then we need to create another line that is basically x-intercept, but about the population mean. So this is about the population mean, and then we need to specify about the color, that is we are going to give the color orange, and then a line type, that is basically dashed. So after giving this line type, and also we need to specify the size, that you can that may vary depending upon your preference. So after about, we need to label it. So in ggplot we can label it by the function labs, and then we need to provide the title of the chart, that is basically I'm going to write it here like z test results distribution curve, and then we need to specify the x-axis by the weight kg, and then we need to specify the y-axis, that is basically density. So now I'm going to show you basically how this graph looks like. So here you can see the output, that this is basically our curve line, that is basically created from this range factor or x value values data that I have created the data frame of x values, and this is basically our orange line, that is basically our population mean, and this is our red line of sample mean. But here we need to also we need to specify, or we want to specify that the orange line is what is representing the orange line. So we need to label these lines. So if you want to label these lines, we need another function, that is basically the annotate. Annotate is basically a function that is used to basically label all the lines in the graph. So as you know that we are going to label the line with the help of the text, and so that's why in the start we have written here the text. Then we need to specify that that we are going to annotate the first line with the sample mean, because because first of all we want to annotate the first line, which is basically this line of the sample mean. And here we will specify that the y is 0.04, it's a size, and then label it. So for label we need to paste like sample mean. Sample mean is equal to, or sample mean is in round sample mean 2, means the value of the sample mean should be round of about the 2. So that's why we use this round name. So after this we need to specify the color. If you want to give like the I have given the red color because sample mean is also given with the written with the line is also plotted with the red color. So that's we need to specify its height like with the adjust, which is equal to 1. Same in this case for the second line is the annotate. We have specified here that the population mean, then we need the label population mean, and also there is no need to round off of the population mean, because the population is mean value is exact value which is basically the 68. So there is no need to round off the population mean, because in sample mean we need to round off, because sometimes it's contain the decimal points. So that's why we round off the sample mean and to use this function. So after running this code, you can see that how the round annotate function works and how it looks like. So this is all the words, that is the sample mean, which is 67.6, and this is the population mean, that is 68. So how now the last thing is that how can we know that either by seeing this graph, that the graphical with the help of this presentation, that either to accept the null hypothesis or to reject the null hypothesis. So this is basically all these area under this blue line is called as the critical region. So if your population mean or if your population mean or sample mean falls in this region, in the critical region, so we need to accept our null hypothesis. So if it's fall in out of the critical region, then we need to reject the null hypothesis and to accept the null hypothesis, alternate hypothesis. So this is all about the z-test and the presentation of this data with the help of the graphical with the help of this ggplot library. So if you have any question related to this, you can comment us, and please subscribe my channel and press the bell icon button. Allah Hafiz.